All right, so how am I going to draw a fuse? I'm going to draw a fuse by taking a wire, and then I'm going to go whoop like this, and I'm going to, right, so this part here would be the fuse. Let me know there's a fuse or a circuit breaker, either one. Next item on my list is something called a voltmeter. A voltmeter measures potential difference or voltage, right? An ammeter. This is going to be tricky. Put an A in there. This means an ammeter is there, right? And there's my two wires coming out of it. Switch. Switches look like this. I'll show you why in a second. All right. Next on my list is something called a short. When having a battery and you have it attached to a resistor, then the electrons, the current flows this way, the electrons flow the other way. They're flowing through my resistor on the back side, providing me power to do what I want to do. Now that's all great and good until something weird happens, like I put a metal pole across here. When I put a metal pole across here, what happens? The electrons have a choice. They can climb Kilimanjaro and get to the other side, or they can take the quick water slide back to the battery. So they're going to take, so what do they end up doing? They all end up taking the water slide to the thing, and so my light no longer turns on, which is kind of a bummer. So we call this a short for shortcut. Okay? It's a short. So if you have a situation where the electrons don't have to go through something, they won't. And so we call that a short. I think the next thing on the list is, we already did what are fuses. Hopefully you wrote that down while I was talking about it. What are circuit breakers? So we're going to do circuit breakers now, and that's the last thing we're going to do on this thing for a little bit, except show you how to draw something, what these things look like. So a circuit breaker is actually an interesting device. It has a metal, it's got a wire coming in, it's got a hinge, it's got another wire coming in like this, and then what happens is it's got a wire wrapped around this wire, like this. Now on the other side, you have another wire that's hooked in, so it touches right there. And it's got on its side another coil going the other way. Now, what happens when this happens? Well, what happens here is some of the current's going to go through the little curly wire. And as it goes through the curly wire, it creates a magnetic field. More on why curly, we're not even sure this right. Why we're just saying, anytime electric current's traveling through a curly wire, it makes a magnetic field. And so this curly wire, before it reattaches there, it's going to make a magnetic field. This one creates a magnetic field the other way. So they're repelling each other when normal amounts of current are going through there, but it's not enough to pop this open. But, ... if your current gets above a certain amperage, like 10 amps, if you've got a 10 amp circuit breaker, what happens is these magnets push against you so hard that they actually pop loose. Okay? And when they pop loose, then the good news is instead of having to go to the store and get yourself another fuse, because a fuse melts, so therefore it's gone forever, all you have to do is snap this back in place. Some require resetting by pulling it farther apart and then snapping it back in place. You should know where your circuit breaker box is in your house. If you parents have never explained you a circuit breaker, part of your homework today is to make sure that you know how a circuit breaker, where your circuit breaker box is for your house, and how to reset a circuit breaker, because Lord knows you're going to be growing up some point and you're going to have to figure this out. And you're going to want to go find the box somewhere in your house and do that. Oftentimes they're outside of your house, by the way, too. In horror movies, that's where they always put them so they can turn off the lights before you get there. How would this turn off your light? If I break the wires going in your house, guess what? You have no lights. Yeah. My circuit breaker box is inside my house. That's inconvenient for firefighters, though. So generally speaking, they want them outside the house. I'm just weird and have it inside my house. Fair enough? All right. So backing up, we want to draw a circuit because all this talking, and I have not yet drawn a circuit, so I'm going to have to do a couple things simultaneously. So here we go. All right, so now I'm going to draw myself a circuit. How do I draw myself a circuit? I'm going to do the same thing. I'm going to make this light bulb light up. First thing I'm going to start the battery. I need a wire coming out from the battery. I'm going to start on the positive side. Again, it doesn't matter. Either one would work. So this thing comes over here, and now I'd like to have a switch on it, but I'm going to do the switch afterwards. I'm going to put it attached to the light first, touch the back of the light, right? Then I'm going to take it to the front to the other side. Now, if I put it here, nothing's going to happen. It's going to be short, right? It doesn't have to go through the light. If I put it on the other side, it has to go through the light to the other side. Now it's going to come out the back side. Now, I told you I want a switch, so I'm going to attach a switch. Boop. Here's my switch. There's a switch. So I've attached to one of the, oh, I'm not right. I've attached to one of the switch. Okay, so a switch looks like this. It's just two metal things, right? This thing comes down. This thing comes down like this. Boop. And that's the switch. Old school switch. That's why it's drawn that way, by the way. Right? Open, no electricity going through. Then when it's closed like this, electricity is going to be able to come through. So I'm going to now on the back side, I'm going to attach to the, oops, no I'm not, here I am. So I'm going to attach to the negative end of the battery. There's the negative in the battery. And I'm going to attach it right to the other side of the switch. Okay, so now I'm coming from the battery to the switch, from the switch, no, from the battery, sorry, to the light, through the light, out to my switch, from my switch, back to the battery. And if I close my switch, therefore letting electrons through, my light turns on. Now, a couple things. One, if I undo this, light comes off. Makes sense because I've broken the circuit. But what's interesting about this is also keep in mind all I've done, the battery's attached still to the back side of the light, right? So the battery's attached to it. Why is it not lighting? Because it's got to get back to the battery. Right? Everything has to get back to the battery. All right? And so that's one thing you need to worry about. Okay? Does that make sense? All right. All right. Now, next thing on the puzzle list is this. I want to know how an ammeter works. Okay? So right here I have a handy-dandy ammeter. It says big A. It's the big A right there. Okay. Now I'm going to probably have to move this closer when I show it to you. Let's show it to you right now. Closer. Okay, now it's at 0, right? See the little red line at 0? Okay, so now I'm going to have to go ahead and see if I can do this without. So an ammeter measures the current going through the wire. So if I want to know what the current's going through the wire, I have to be in the wire, right? So I'm going to take the same situation, and I'm going to, instead of going back to the battery, I'm going to go from the switch. I'm going to go from the switch to the ammeter. So it goes in one side of the ammeter. And then, so I'm attaching the ammeter on one side. And then I'm going to come out the back side of the ammeter and I'm going to attach it to the battery. Attach it to the battery. Let's see if I can do this without hurting myself. Okay. Okay, so light turns on. Light turns on. Okay, so it's really hard to see the little needle back in the back, so I'm going to move the needle up so you can see it a little closer. So when I flip the switch, you can kind of see, yeah, hopefully you can see the needle if you really got a high resolution screen. Let's see if I can turn it. No. If I move it, it makes it easier to see, right? So there it's going, there it's not. No current, yes current. Okay, all right. Voltmeters work the same way. You just, you don't have to have the current going through it, so you're going to attach it in what we're going to call parallel. We know what parallel is, so that's not that important. Here's a voltmeter. They look the same way. In fact, secretly, ammeters and voltmeters are the same device, just one of them has enough resistance, has a specific resistance associated with it, so therefore you can figure out what voltage is, because current times resistance is voltage, right? All right, I think I've got everything explained. Oh, we didn't draw it. We didn't draw the circuit. So let's draw a simple circuit. So I have my battery to my light to my switch to my ammeter back to my battery. Let's draw this thing out. So I'm going to start at my battery. Whoop, very good. Where the heck is my brush? There it is. So I'm going to start my battery. I'm going to draw it something like this, right? I'm coming out from my battery to the light. Boop, 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 boop. Okay, from the light to a switch. From the switch, I went into an ammeter. From the ammeter, I went right back to the battery. And so I've just drawn my circuit. Okay? That's how you draw circuits. Okay? All right, so here's what I'm going to ask you to do. I'm going to ask you, you're going to have to do problem 9, you have to have worksheet 9-7. I'd like you to jump ahead and start right on number 11. Let's start right on 11. I'm going to do 11 in just a little bit, so we'll count it down. So go get out 11, take a look at number 11, and then try out number 11, and then I'll do it with you in just a second, okay? All right, and then we're pretty much done for today except for doing homework and classwork and all that sort of nonsense. All right, here we go. Again, if you haven't tried number 11, please try number 11 before I do it for you right now. Here I'm doing number 11 right now. So 11, and this is on 9-7, doing number, boop. So 9-7, number 11. What is 9-7, number 11? It says draw a schematic to show a circuit. Just saying draw a circuit's good enough, by the way, for this, for the wordage, with a 90-volt battery. 90-volt battery. Technically, I should be drawing like 1.5, 60 cells. Not going to do it. Too lazy. All right, and an ammeter. So, where do I put the ammeter? Anywhere. I could put it here. I could put it here. I could put it on the back side somewhere. Don't matter. I'm going to put it here because I'm, enjoying myself. And then it says I need a resistance of 45 ohms. So this is a 90-volt battery, so I'd label it 90 volts. And I'm coming down the back side. I need a resistor. So I could put a resistor up here, put a resistor down here. I could put a resistor right next to my ammeter if I want to. I'm going to put it over here. It doesn't matter. All that's good, right? So if I have my resistance is, what does it say, 45 ohms? Now the next question is, so that's my circuit. I've successfully drawn my circle. It doesn't ask for a switch, so I have no switches. So therefore, all I have to do is do V equals IR. 90 equals I times 45. I equals 2 amps. And that's how you do those. And so 9-7 doesn't ask you to draw for all of them. You can draw them for all of them if you want to be creative. But starting at 11, it asks you to draw them. And now you know how to draw a circuit. By the way, this is how the real people draw circuits. So if you crack open some sort of crazy electronic device, oftentimes they already have the circuit drawing there. You can start understanding what's in there. A couple devices you won't understand in there, but right now you'll recognize resistors, you'll recognize power supplies. They're always in those things. Generally speaking, they'll put ammeres, voltmeters. That's more of a physics teacher sort of thing. All right. Talk to you. If you got questions, send me emails. Again, I'm going to have students do various problems, and I'm going to be monitoring them. By the way, one thing I noticed is when I write, oops, there's a mistake here, you need to do this instead, I'm not seeing people correct their mistakes. You're not required to, okay? But I'm going to come back behind you and correct them, give you a chance to correct them before I move on. Just be that may. And thank you, Ms. Flynn, for catching my mistakes on the earlier one. All right. Tell me if you got problems. Let me know what they are. I am going to assume you're good unless I hear from you.